So, have you ever tried to wrap your head around a structure so massively enormous that it kind of practically defies human comprehension? Well, today we are focusing on a true titan, the Three Gorges Dam in China. Rising straight out of the waters of the mighty Yangtze River, you gotta understand, this isn't just a large concrete wall. It's actually the biggest concrete structure on the entire planet. To put this in perspective, just imagine a building standing 60 stories tall and then stretch that building out for over 2 kilometers across a raging river. It took 40,000 workers over 17 years to construct the whole shebang. It is genuinely terrifying in its magnitude, yet absolutely magnificent in its engineering. And get this, the planetary impact of this project is just staggering. When the massive reservoir behind this dam was finally filled, the concentrated mass of all that relocated water was so heavy, it actually slowed down the speed of the Earth's rotation by a fraction. No way, right? But look, a behemoth like this doesn't just appear out of nowhere. It wasn't dreamed up overnight. The Three Gorges Dam is actually the ultimate culmination of what's basically a generational engineering relay race.
You see, we are really standing on the shoulders of giants here. The success of the Three Gorges relies on a series of historic leaps forward, spanning from 19th century Britain through mid-century France and America to the Soviet Union, before finally landing in modern-day China. Each of these historic dams solved one massive, seemingly impossible problem, and then they literally passed the baton to the next generation. So let's trace exactly how we got from a tiny stream to a structure that alters the Earth's spin.
All right, let's jump right into Section 1, the Mega Dam Blueprint. So the origins of the world's greatest hydroelectric dams actually start way back in 1878 with this wealthy, kind of obsessive inventor named Lord Armstrong. And he really just wanted a way to light up his gloomy picture gallery so he could show off his Victorian paintings at night. So he built a simple earth wall to turn a small stream in Northumberland into a deep lake. This powered a turbine that generated about 4,000 watts. The crazy part, he had to use 5 tons of thick copper wire just to carry that electricity a kilometer up to his mansion, all to power a single light bulb. Now, jump forward to the Three Gorges Dam today. It produces over 20,000 megawatts. That's twice as much power as all the nuclear power stations in Britain put together. It's generating enough electricity for 60 million people. Now, you might be wondering, how do we actually capture that massive amount of energy? Well, it all comes down to 3 basic steps. First, water from that massive reservoir is channeled down gigantic concrete tubes. Second, that high-pressure torrent hits and furiously spins the turbines. And third, magnets attached to a rotor move past copper coils to generate an electric pulse. What is absolutely mind-blowing here is that the basic mechanism Michael Faraday discovered back in the 1800s is the exact same concept driving the 32 massive, $50 million generators inside the Three Gorges Dam today. The science hasn't changed at all, just the scale.
Which brings us to Section 2, Taming the River.
Think about this for a second. Before you can even generate power, how do you physically pour millions of tons of concrete into a raging 2-kilometer-wide river like the Yangtze without it just immediately washing away, right? You can't just dump it in the water. Well, to answer that, we look back to 1914 France during a major wartime energy crisis. French engineers working on the fast-flowing Dordogne River invented this clever little loop called a cofferdam. Step 1, they blasted diversion tunnels right through solid rock. Step 2, they built temporary dams upstream and downstream to force the river into those new tunnels. And Step 3, they drained the trapped water in the middle, leaving a perfectly dry spot on the solid rock riverbed so they could build the main dam. This brilliant technique from the Marage's dam literally became the blueprint for everything that followed. But, of course, the Chinese engineers at the Three Gorges had to level this up drastically. See, the French engineers built their cofferdam and simply let the new reservoir swallow it underwater when they were done. But the Chinese temporary concrete cofferdam was way too massive to just leave behind. So they used 190 tons of dynamite. Once the main dam was safe and secure behind it, they packed that temporary wall with explosives and, in a matter of seconds, blew it to absolute pieces, unleashing the mighty Yangtze River back into its natural, albeit now controlled, course.
Moving right along to Section 3, Surviving Concrete Heat.
To understand this truly bizarre enemy of megastructures, we gotta look to the 1930s American West and the pouring of a literal mountain of concrete for the Hoover Dam. The problem: how do you cool 6 million tons of concrete quickly? It sounds absurd, But as concrete sets, a chemical reaction causes it to generate massive amounts of heat. Like if they had poured the Hoover Dam all at once, the sheer scale of the heat generated would have been enough to bake 500,000 loaves of bread every single day for 3 years. Because the outside of the dam would cool faster than the inside, the expanding heat in the core would have caused the whole thing to violently crack. Left alone, it would have taken 125 years for that structure to safely cool down. 125 years. Well, the man in charge, famously known as Hurry Up Crow, obviously couldn't wait a century, so he devised this truly ingenious internal plumbing system. First, they poured the concrete in small, individual interlocking blocks rather than one giant continuous slab. Second, they embedded over 950 kilometers of steel pipes directly into those blocks. And finally, they built a massive chilling factory and pumped freezing Colorado River water right through the core. This giant internal refrigerator shrank the cooling time from 125 years down to an incredible 22 months, completely preventing any catastrophic cracking.
So the crucial point here is, how on earth do you scale that cooling concept up to the Three Gorges Dam? I mean, they used 28 million cubic meters of concrete. To put that in perspective, that volume is equivalent to a solid meter-thick pipe wrapping entirely around the Earth. So they used every trick in the book. They pre-cooled the raw materials or aggregates before mixing them. They literally threw ice straight into the cement mix. And because they were dealing with blazing summer heat, they even set up a massive fog spray system over the top of the dam to cast a continuous blanket of shade. It blocked the intense solar radiation from baking the curing concrete. Just brilliant.
Next up, Section 4, Surviving the Flood. Okay, what happens when it rains relentlessly and 22 billion cubic meters of water threatens to violently breach a dam? Well, the primary danger is something called tow scour. If water just pours over the top of a dam and crashes straight down, it erodes the ground directly in front of the dam. It literally washes away the foundation, causing the entire concrete structure to rotate forward and completely collapse. And we know exactly how deadly this is because of the 1889 Johnstown flood in Pennsylvania. Heavy rains breached a dam there, unleashing 20 million tons of water in just 45 minutes. It created an 18-meter-high wall of destruction that took over 2,200 lives. So tow scour is an engineering nightmare that absolutely had to be solved. Back in the 1930s, American engineers at the Grand Coulee Dam solved this by building an underwater concrete ramp. When water rushes over, it hits this ramp and forms a tumbling underwater vortex, which gracefully dissipates all that destructive energy. But Chinese engineers at the Three Gorges, they went a totally different route. They decided to violently launch the water instead. They built these massive concrete chutes that hurled the floodwater 100 meters down and out into the empty air. Once it's airborne, all that massive force just breaks apart into atomized droplets, safely landing far downstream without digging into the dam's foundation at all. Finally, let's look at Section 5, Navigating Ships and Silt. So when you block an active, vital waterway, you don't just stop water, right? You're blocking heavy human transport. To solve this, back in the 1960s, Soviet engineers built the Krasnoyarsk Dam across a massive shipping route in Siberia. To keep the ships moving, they essentially used the principle of a squashed hot water bottle. By using liquid under immense pressure, basically giant hydraulics, they pushed a steel trough holding a 7,000-ton ship up a ramp, right over a 1-kilometer-wide dam and down the other side. And they did it all in 90 minutes. The Three Gorges took that concept and turned it into a literal mega elevator. The Yangtze has about 170 ships passing through every single day. The traditional 5-tier water locks take up to 4 painful hours to traverse, which is just way too slow for passenger boats. So they built this massive vertical lift instead. Step 1, the ship floats into a giant steel trough. Step 2, 16 separate 1,000-ton concrete counterweights drop down inside the dam walls. And step 3, this counterbalance effortlessly hoists the ship 113 meters straight up into the air in just 36 minutes. It is an absolute marvel of efficiency. But listen, there is a silent killer for dams, and it's not ships or heat. It's mud. Specifically, Mother Nature's silt cocktail. Floodwaters mash up topsoil, snail shells, decaying vegetation, nitrogen, and phosphorus into this vital nutrient smoothie for downstream farmlands. We saw the danger of blocking this back in 1970 when the Aswan High Dam in Egypt completely starved downstream farmers of these exact nutrients, forcing them to rely on millions of tons of artificial fertilizer just to survive.
And the sheer scale of this threat to the Three Gorges is honestly terrifying. 500 million tons of silt. That is how much sediment the Yangtze River drags down every single year. That volume is enough to fill giant sports stadiums hundreds of times over. If all of that just settles in the slow-moving reservoir behind the dam, it doesn't just rob those downstream farmers of nutrients. It will literally fill up the entire reservoir and choke those massive, expensive power-generating turbines to a grinding halt.
So the multi-million-dollar question is, how do you empty a bathtub full of 500 million tons of mud? Well, the engineers installed giant sluice gates deep down inside the base of the dam itself. Each one of these gates weighs as much as a city bus. When they open these gates, they actually use the river's own terrifying, violent floodwaters to scour the bottom of the reservoir, forcefully flushing all that trapped sediment right through the dam and safely down the river. It's this incredibly elegant self-cleaning solution that preserves both the natural ecosystem and those $50 million turbines.
Which brings us to the ultimate question. From Lord Armstrong's tiny little stream to a concrete monolith that actually altered the spin of the Earth, the Three Gorges Dam is simply the current pinnacle of an incredible generational relay race. It stands squarely on the shoulders of every historic failure and triumph we've explored today. So I'll leave you with this thought. Considering what we've conquered over the last 150 years, what limits will human engineering break next? Like, what will our next impossible megastructure even look like? Think on that for a bit. Thanks so much for joining me on this explainer, and keep your curiosity flowing.